So now I'm on his branch, so this should just run. Let's just make sure this runs. Yes, but let's do a jack clean first, because there's cached files that sometimes can affect running jack. Okay, that was a fresh, uncached run. We have our type information and we have our symbol table information. And remember, the goal right now is for us to leverage Mypy as the official type checker for Jack. Since Jack is a supersetted language of Python, and it's a proper native superset where there is no interoperability link between the language and some runtime. The language targets pure Python bytecode. Given that the semantics are equivalent of the objects in the type system, at the bytecode layer, we can leverage the ecosystem of analyses and tools to support, to be the engine that checks Jack code, right? You just have to bridge that linkage by taking advantage of some of the beauty of Python's design when it comes to its internal representations, right? How everything is really, you can muddle with the internal representations from the language level. I mean, it's really a feat of engineering. Python is so special. It's more special than it seems, right? Because it's obvious that it's special because it's a beautiful language to code in, but the engineering artifact that is the design of the code base and how modular and open it is makes it a playground for supersetting. It's wild. It's like crazy. Anyway, I'm not aware of other languages that superset it in the way that Jack supersets Python, which is something I'm excited about. Okay, but now we got to fix this thing. So the key thing I want to look at first is there's nodes that don't have Mypy nodes associated with it. So let's zoom in on that. So I'm thinking about how to approaching this problem. So there's circle.jack. I don't want to start there. Let's start with something simpler, and let's just get one isolated case of non-linkage between a Mypy AST node and Jack's AST node. So if we do that, we'll start with not reference. We're going to go to micro, and then we're going to run his Jack run tool stuff on func.jack, because we do have some of those cases in func.jack, and func.jack is very simple to grok, right? So this is func.jack. Very simple lines of code. We have the types information. Of course, this one has no type, which is an int1. That's on line. The way I read this is line 1235 to line 1236. So that's this number. Of course, that should be not no type. That should be an int. But what I'm going to check now is whether or not on this line and this character width, whether or not this is one of the places where we do not have a Mypy associated AST node. And it appears it's not one of such places, because we don't see 12 here. We don't see it here. This is the places that I'm looking at. So let's start here then, and then look at the code to see if we should have a type associated to it. So this is line 3, character 5 to character 13. So it's factorial. So the AST node for factorial does not have a Mypy type associated to it. Now, the part of this code base that has the association, that does the associating work, is this type check pass. Type check pass is the pass that turns Mypy into a library and kind of digs into Mypy and then uses its guts as like a library. Mypy was not designed to be a library. So this is some pretty, like clever, tentacles in architecture. So okay. Yeah. So basically, there's this AST converter pass. Basically, we literally inject the Python AST representation of a Jack AST into this particular hook point into Mypy's library. Whoa, that's loud. Sorry about that. I don't know even how to silence that. We'll just have to deal with it. Hey. So we're gonna hook into Mypy through this particular hook point. So the way this is architected is such that in the vendor directory, I can have essentially an untainted, untouched folder that has Mypy's code base in it. So it's called vendoring an existing open source project. And so in the vendor directory, it's just the code is there so that you don't have to have a dependency in the package. All the dependencies are built in, but a clever way to do that is you'd want to be able to upgrade that vendor code base by moving it directly into that vendor directory. So when Mypy 1.9 or 2.0 comes out, I can move it in, and then I can adapt, and I can upgrade the adapter into Mypy's guts, right? And so this file here is that adapter. This essentially pulls in all of the Mypy vendored code that I want to change to allow for customizing how I'm leveraging the engine. So build manager. So and these are aspects of Mypy that I do that. Now there's this AST converter, and this is where we inject our own Python AST representation into the Mypy engine. And when we do that, there's a piece of this code, node.jacklink, like these lines of code, essentially maintain the linkage between the Jack AST node and its equivalent Python node and its equivalent Mypy node, right? And so when we do node.jacklink.gen Mypy AST append ret, we're appending the output of the Mypy converter, which walks the Python tree to populate the Jack node with a link to its Mypy equivalent. So the fact that we have Jack nodes that doesn't have a Mypy node associated to it, it means somehow there was a Python node present here that doesn't have this Jack link. It doesn't have a Jack. It's not linked to a Jack node. So at the end of the day, that means that when we're generating Python nodes, there's some nodes that don't have. It doesn't have a Python node. Basically, every node in this pass, right? This pass is a visitor essentially of all the Jack nodes, and then it generates a Python equivalent. So there must be some functions here. Which function? We know here that factorial is a function call. It's a function definition. So I would expect that this name factorial doesn't get populated with the output of the code generation to the AST node for a function. So let me just go do that right now. I think I know exactly where all of these non-links are happening. Now that I've talked about it a little bit. So basically, we have a function. No, it's called abilities in this language. So exit ability is essentially exit function node. There's a very good reason we call functions abilities in Jack. Essentially, ability can be one thing or a function. Some of this naming nomenclature is going to evolve over time. and and we'll see how it evolves. But we're kind of like really honing into this concept of ability. All of this is going to be written about in very clear details. Like functions are a type of ability on an object in the nomenclature of Jack. But there's another thing that is also an ability that's not a function, that is a new concept. It's a new kind of code construct in the language, part of the superset stuff. Anyway, so we do generate a node, right? So this is a Python 3 node. Whenever you see AST3, it's a Python 3 node. Whenever you see AST, it's a Jack node. I realize that could lead to confusion in some of these choices to, AST3 versus AST, but these are two different types of ASTs. A better naming would be PyAST and Jack AST, but whatever. I'll probably change that at some point. I won't do it here and spend time off topic. Okay, so what's the fix? So the fix is, if we look at the AST itself, right, and I'm going to clear out all the others so I don't get too many files here, but if we look at the abstract syntax tree AST itself, the abstract AST is, for an ability, is here. So this is an ability AST node. An ability has a number of other nodes that could be its children, essentially. All I have to do, honestly, to solve this... I'm thinking about an elegant solution that's simple. Let me just describe the solution. The solution to solve this, and I think the problem is... Let me explain the problem. So the problem is, there's an AST node for a name. Right? So in a function, it has your keyword, def, or can in this case. It's got the name of the function. It's got your signature, open parenthesis, whatever. It's got all that stuff. Those are multiple individual AST nodes. Now, when we do the AST gen, we do one for the function. In principle, we should generate nodes for all of the children too. But it may not always be the case. I can force it to be the case. Let me just see if I gotta test this, right? Because I'm thinking as I do this. Let me test something. So what I'm going to test here is if this node, this is the link to the Python node to the current Jack node. If this list this is where we create the AST node that's Python, and we attach it to this function. When we do this here, there is some other Python node for name that's attached to name. However, if we look at the PyAST, I'm actually thinking while I talk about this stuff, if you look at the PyAST, the name is an identifier. It's a flat string, it's not an AST node. So whenever we have that, we're gonna have a Jack node, like in this case, that doesn't have a Python node, right? Because Python doesn't use an AST node for this name of the function, but the Jack AST uses an AST node for its name. Yeah. And so when you guys see me do that, I'm agreeing with the chat. But I don't want to lose my train of thought because yeah. But yeah, so I'll just say yeah. Yeah, and so we don't have that. We don't have that symmetry, and so we'll have Jack AST nodes hanging around without an associated Python node. So Mypy never sees a Python node to attach its Mypy node to, in order for us to keep the links. And so we can solve this simply by finding, I mean, the hard way to do it, I'm trying to find an elegant way to do it, but the hard way to do it is to find in this massive pass, 3,000 lines, find all the places where we're generating a Python AST in which there's nodes being lost, and then just in those code locations on these 3,000 files, make that association. Just specify that, oh yeah, this function node also corresponds to the semantic information of that name node as well. So that's how we can fix this particular problem if we want a one-to-one mapping, or an all-to-all mapping. Let's not say one-to-one. All-to-all is also technically not correct. We have a complete mapping to Jack AST node. There's an association of at least one or more Mypy nodes to each Jack AST node. So, okay. So what does that mean? So we can do that. That's going to be a lot of work. A more elegant solution could be to resolve this recursively and automatically. And I'm thinking to myself how to do that. In the code base. So one way, we do have this sync function. We call sync on the PyAST nodes though, so that wouldn't work. I mean, there is a simple approach, a very elegant simple approach. I'm just thinking if it's too slow. Like, the simple approach is to just do a quick traversal of the tree after and find all of the nodes that are missing ASTs and just walk upward in the tree to the first available Python node and associate it. I'm thinking if I like that solution. I don't know if I like that solution because it's slow. It works. It's slow. It's highly readable. It's highly maintainable. But it seems like you can achieve readability and maintainability with a simpler solution. So let me think. What would be simpler than that? The most readable and maintainable would be to put it the most readable would be to put this everywhere, not necessarily the most maintainable. These decisions matter a lot to me because as the maintainer and the creator of this project, like, putting the foundation down, it's really important that you create a core that is easy to maintain for the longevity of the project, right? And easy to read, because there'll be potentially hundreds or thousands of people contributing to this code base in the future, which is always the goal and the hope. But these decisions matter a lot early on. So, let's see. We can walk the tree and do that. Or we could do it in situ at every location. I'm trying to think if there's a recursive way to identify this on the walk. Oh, dude, it's relatively easy. Wait, it's relatively easy. Oh, dude, you want to know what's really, really, really cute solution to this? You want to know what's a really cute solution to this? Basically, I can actually add a hook to every node visited on the walk. Just a general hook to do every time. And then I can run through all of the fields in a generic way, run through all the fields in the Python AST object, and if it's not an identifier or a list of nodes, how would I check if it's a list of, check the type of this aggregate type in Mypy? If I can use introspection to find all of the locations we have identifiers or nodes not attached, I think that might not be an elegant, feasible solution, but it would be cute if I could check. I can have one function that's called automatically for every node, and it'll check to see if there's any identifiers, and it'll attach the Python node to that identifier. So that would solve it. But it's beyond identifier. There's also there's a couple of these, right? There's identifier. No, it's just identifier. I think I only need to do it with names. Let's validate that. Param_var. Is this just a name? Let's see. This is func.jack. Line 315. No, that we just did that one. Oh, that's a param_var. Oh yeah, it's probably, yeah, it's this one. Param_var doesn't have a Mypy node. Let's look for, what does param_var turn into? Param_var turns into an arg. Does arg have, yeah, look at that, arg identifier. So this is corresponds to this particular thing. So so that might be just the solution. Where we have an identifier, we should just So I'm trying to solve this. Let's see, in the most elegant way. I have this sync, but this sync happens when you. Oh, wait. All right. Let's see. Let me see something. In this sync. Oops. What did I just tap? What just happened? Nope. Stop. What are you doing? Oh man, I just hit one key and this is happening. I'll just close that. Okay. Okay. Let's go back to where I was. Which was sync. Just shift click it. Control click it. So in sync, this is for every node that's generated by this pass, there will be a sync. And when we do a sync, we do have the target node that we're going to sync to, which is the Jack node. What I could do is I can check to see if there are any. All right, I'm going to do the readable but less maintainable thing. I'll do the highly readable, less maintainable thing for now, and then I'll just improve it in a refactor later. So that really is tedious. Let's see. Is there a fast way to do this? Yes, there is. There is a fast way to do this. Let's look at a number of instances of identifier. This will be the most intuitive way. There's 19 instances of identifier. So, oh, you guys can see that. There's 19 instances of identifier. And so what I'll do is I'll just find those 19 code locations here and see if this goes down to 0. So, and I'll just make the change on those 19 code places. So, exception handler. Where do I generate an exception handler? Exit except. So this is one of those locations. This is, you'll see why I don't like this for maintainability. But I'll do it. Basically, so it would be node.name. Oh, the name is optional. Okay, node.name. So basically, we set this name to be this node. Actually, to tell you the truth, I should just create a general function that'll wrap this. It'll be a little bit neater. So I can say sync, what is it called? Identifier, what, like link identifier? Yeah, let's do it that way. So I'm going to create something called link identifier right under sync. All right, let's go to sync. I know I left that code broken, but whatever. So we'll do a def link ident. And then let's see what our Jippity tells us, our generative pre-trained transformer. This is not correct, of course. So we're going to link the identity, which means there's going to be a name node for which we have to. So there's going to be our Pi node, which is of type T. The Pi node needs to, actually our Jack node is actually the target. and then the pi node. Oh well, it could be a list or a. It could be a list or a. Is it always a node? Yeah, it's always one node, right? I think so. All right, let's go with one node first. Keep it simple. So then the pi node would be AST3. Remember that's our Python. AST. I don't know if it returns a T. Link is a none. Okay, that's better. You think our Gypity will do better with the order of the types? Probably not. No, that's incorrect. Link jack name to pi AST. And so let's see what happens. No, it's still wrong. Yeah, these Gypities are not as helpful with sophisticated code bases, I guess, or specialized code bases. So what we want to do here is we take the jack node. Yes, that's it. So we'll just do that. It's very simple. I mean, what? Pi AST. No, that's correct. See, type. This is why it's good to have a well-typed code base. It needs to look like this. Yeah. So that passes our type check. No red line. And now let's go to exception handler. Accept handler. Gosh. And then let us call this one in link ident. It takes another parameter, so that's going to give us a red line, but it should be just node. No, it's not send name. It's node.name. So we're going to link node.name. Let's use quargs so it's clear. Pi node equals jack node. Sorry. Equals node.name, pi node equals, oh shoot. Oh well, this was a silly idea. It was a silly idea because I need to link it with the return of this, so it's not cleaner. Actually, I'm adding complexity because the way I would have to do that one is I would have to do it here. I'll leave it this way though for now. I don't know if I like the added function call when it's not necessary. No, that's not right. That's not right. Node.name equals I'm gonna change the link ident. I'm likely gonna revisit this and refactor it to be a little bit more elegant. I'm gonna make this a list because every so then we don't have to do this. And it's just for type, more type elegance. Let's see. And then this is not this. But why is node.name? Oh. If node.name. Because node.name could be null. Now, thank you very much. So I have to do this in 19 places. What I'm going to do though, because the more efficient way to do this would be to actually apply it to one of these and see if we get less errors. First, I'm going to run this and see if I broke anything. Let me do a jack clean. So at least my code is clean. Yes, so the code is clean. I didn't make any mistakes thus far. But what I will do is let's find the location of that particular error. So let's look at factorial. Factorial would be in functions, which are called abilities. So in this particular one, we'll need to link on, because in that function type, no, function def. In this one, we know that name is an identifier, and then name becomes value. Where's the name? Where is the function name? What? This is the function? Okay. It's at the end. So name is node ref, sim name, name ref. So what we'll do is we'll just add that code here. In this case, it shouldn't be optional. Link ident node dot name ref. I'm just gonna leave off the quarks. I feel like quarks are really, really nice because it increases readability a lot. I even considered in the Jack language mandating quarks where possible because it increases readability so much. And code is read, I mean, fun fact, code is read like 1,000x more times than it's written, you know? It's true, facts. I don't know about 1,000x, but there was a study. I'm saying 1,000x, it's a lot more. It's a lot more. There was a study where it's some interesting number of x more than it's written. It's read. And so sometimes we make a lot of decisions to make writing code easier, but really we should lean our decisions to make reading of the code easier. So I'm going to go ahead and do it because, I don't know. Like I said, being on stream makes you more accountable to making good decisions. Anyway, all right. So if this is legit, if this is not wasted work doing this 19 times, this one should go away from this change. So this error should go away. Moment of truth, guys. Let's do a Jack clean, just so we don't trip ourselves up. And then Jack run. Now we're going to scroll up, and we hope to not see factorial. Up, and we see factorial. Wonderful. Why didn't that do it? All right. Let's see. Do I set this anywhere else? Exitability. This is where I set it. I associate the Pi node to this. Oh. This isn't a complete solution. We may have still found the issue, but it's not a complete solution. And it's not a complete solution because Jack link let me tell you why it's not a complete solution. So if you have a Python AST node and then you have a Jack AST node, what we're doing is let's draw it like this. This is the Python, this is the Jack. Okay? This is a function in Jack. This is a function in Pi. Basically, Pi actually just has a string here. It's just a string for the name. The name is just a string inside the node. It's not a name node. In Jack, it's a name node, right? And so we have this is a name, right? Which is an AST node. Now, what I'm trying to do is for every single Jack function, for every single Jack AST node, we have a corresponding Python AST node. So then what I'm doing, and that's recorded in, I'm thinking. So we have this link, basically, and then we have this link, and then we're drawing a link. We just created a link, and the link we just created was to link this Python node. But when we did this link, these are two-way links. Let me just explain. Okay. This is a two-way link. But what we just did here is we did a one-way link. Right? So from the perspective of this node points to only one Jack node because we don't have a link here. And so when we do the Mypy, we put it into the Mypy checker, whatever. Mypy is trying to link back, right, from the node and say, oh, guess what? I just created a Mypy node for you, Funk. Now, and it's using this arrow to then say, oh, okay, guess what? Node, create a link here. So now this node knows about both its Python node and its Mypy checker node. However, it only updates here, it only updates this node even though we have a link in this direction from this node. So I have to create a link to the direction back here too. Problem is the code base is designed such that the spot for linking back, it's not a list. Like there's a list of Mypy nodes, but there's not a list. There's a list of Mypy nodes associated to every Jack AST, but we don't have a list of Jack nodes associated to every Mypy AST. So there's only one spot for a link back, basically. And so we're not even updating that spot in my implementation thus far. But the problem is becomes a bigger implementation because I'm gonna have to change a deeper kind of assumption. I'm gonna change the code to map to a deeper assumption, which is every Python node links to a single Jack node. The correct assumption now is every Py node could link to multiple Jack nodes. And so to correct that, it's actually not that hard. It's just I don't know how much code I'm gonna have to update. But to correct that, just for this one use case that we want to prove the solution before we apply it everywhere. Let me see. It's the sync, right? Now, the good news is this shit is not like properly type checked. I'm gonna have to change a couple. This thing is not properly type checked because this is called monkey patching. And it's not type. You have to type ignore when your monkey patches. As far as hey, correct me if I'm wrong. Anyone, please email me, contact me. If you find a good solution for in a type safe way monkey patch in some kind of type framework, just let me know about it because I haven't found it. I searched for like 3 hours once. I couldn't find a good, elegant way to monkey patch. This was the most elegant way. Now this is monkey patching, and this isn't even type, but I'm gonna actually type it. I'm going to type it just for readability. But this monkey patch is currently AST3 AST, right? This is actually, let me see what happens if I get rid of the type ignore actually. When I do that. Yeah, it's like AST has no attribute, blah, whatever. So I'm monkey patching in this link, but basically I have to turn this into a list. This is the solution so you can really fully understand what I'm talking about. This has to be a list because we can have multiple, because we have multiple arrows, like we have multiple arrows like that, that means we have to have a list of such associations here, right? And so that's the update I'm gonna have to do, which is weird because I have to find all the locations I reference Jack link. It's not that many. And then I'm gonna have to make sure that it all checks out, right? So I'm gonna do this, and then I might have to, I have so much, I just skip meetings because this is important sometimes. So I gotta get this work done. But I have a meeting, whatever. but I'm gonna finish. I'm gonna get here hooker by crook where this goes away. Okay, so Jack link AST. That's fixed from a type annotation perspective. Let's fix it everywhere else now. Okay, that's the first one. Okay, this is the second one. Oh, it's good I have this function, because in this function then, this is the solution. I think it'll be quicker than I anticipated. It would be pi node. No, this had it right. For I in pi node. Oh, is it gonna do it? Close, close. Append. And I'm not gonna do the type check. Right? Of course this won't match the is instance, but is Mypy smart enough to know that jacklink is a list from my prior annotation? Let's put an annotation here. Maybe it can tell if I put a AST3, AST. Come on, Mypy. Every single definition of this is annotated. Nope, not smart enough. Okay, cool. Oop, let's just put it in there. But here's the issue with is instance. You can only check that it's a list, as far as I know. Please correct me if I'm wrong, guys. That should go away. Why isn't it going away? No, if I.jacklink. Anyway, you see the importance of type safety. Like, okay, well, oh, AST has no. Of course it has no jacklink. So because this is a monkey patch thing, I'm gonna type ignore it. I hate using type ignores, guys. Like, you should not do this. But this is a very sophisticated piece of infrastructure. And so the monkey patching is necessary here because this is like the only place in the code base we do monkey patching. No, that's a lie. There's like 2 places in the code base we do monkey patching. And the code base is like, I don't know, 20,000 lines of code. It's crazy. Okay, so we have that fixed. So now we're linking it back, but our types aren't consistent throughout the rest of the whole application code base. So we're gonna have to go through one by one and just check these, comment it out. This is wrong. This is wrong already. See, this is why type ignore that. That would have been an error. That could have taken 5 minutes to find. So that has to be a list of nodes. This is fine because we're doing an append. We're appending it when we do the link. We're linking an identity string identifier. We're linking an identifier. Some may argue we should name change this to be the whole word for readability, and I'm going to do it because I'm less lazy on stream. Identifier. Okay, that should change it everywhere. I did F2. It's yeah. Thank you, VS Code. So we have it correct there. How about here? That's okay. How about here? Oh shit! Are people pinging me on this thing? Okay. This one's here. Has attribute. That's okay. If not is instance blah blah blah. Self assert true has attribute. Why do I have this? Oh, this is a test. Okay. Assert AST converter. Here we go. This we're gonna have to change. This turns into a nope. Come on. Sometimes it's faster to just sometimes it's faster to just type it out than even wait for the jacklink I. Okay, that's good. Equals jacklink. What? Yes. Wait. This is gonna turn into a list too. How many places do I reference this? 4. Fuck. Oh, I just have to update the types here. This is a list of AST nodes. And there's only 4 places. This is the only file that uses this table. I just have this table just in case. What is this? My project. Node override. Oh, I'll just use the first one. I'll use the first one. Yeah, I'm just updating the entire code base to now assume that this location is a list. Whoop. This location is a list. If you guys remember what that picture means, because it's all scratches now. So this is good. This is type checking out. That's good. Except that this is wrong. But it doesn't know what jacklink is. That's why it's not highlighted. So this is wrong because... No, it's not wrong. It's right. Because we're updating this to be a link. So, okay, that was that one. So this should be good. That's good. This should be good. What's this stuff? This is just notes. Okay. All right. Well, let's run stuff and see what the hell breaks. Because that much code... That much code stuff is going to break. What? Why is it breaking silently? It's suffering a very silent death right now. Okay. Let's think about this. Jacklink would be the places to check. Jacklink is never not a list. I don't know why it's dying silently like that. Error occurred while. So all right, let's try to get more error information. Of course, using a debugger is probably the right move, which I may do, but I'm gonna just try to do this quick. Let's do a raise. Raisey after. Why wouldn't I have E? Oh, I should just put it in here. Let's just do it like that. Yeah, you have a little bit of a prettier output because I just want to know what. I just want a hint. Let's do Jacqueline. Well, run doesn't have the raise. That's why. So this is tool. So I gotta go to tool. List indices must be integers or slices, not string. Let's raise E. See if we get a stack trace. Yes, we do. Right here. Okay, so we have a stack trace. Oh, okay. The fuck? Why would... Oh, here. Right. List indices must be integers. Oh. Oh, fuck. Sorry. If you guys know what I'm coding here, I'll talk through it. I really want the indice of jacklink. Yeah. So I did the classic. See, this is... Jack solves this. We have iterators. We have like the C++ style for I equals 0, I less than 10, I plus plus is in Jack. And it also has all of this stuff because it supersets Python. But if you have that, you would never use this. And that's a, I've run into that error 17,000 times in my life. I've been doing this forever. And that's an issue. That's costing me productivity. So that's fixed. That's fixed in Jack. Okay, so it works. That was the only error. Now, let's check the moment of truth. Is name there? No, but we have other weird errors? Well, I think there's good news and bad news. The good news is I don't see factorial. So at least the hypothesis as to what's wrong is correct. The solution is not done and is not correct because there's an issue here. What is this issue? Should be easy. Oh, okay. Now this is an issue inside of. This is inside of. I broke something in his commit, in his code commit. Enter name. Oh, of course, because he wasn't able to test this because this wouldn't run sometimes. Why would this? It's a funcdef. Has no attribute node. Oh. This is type stuff. This is his, like I might need him to look at this, but I can fix this. I can fix this in a kind of a temp way. Because he's making an assumption about the elements that are in here are symbol table elements. I mean, are elements that are children of, like they can be they can be symbols, right, with types. So this is an assumption. How can I check what type he's expecting that has nodes? Let me see if I can find another instance of this where I can know. So there's some type. This is any. So I'm not gonna get a good hint. It's sage knowledge right now. What has node? I mean, I know how to find it, dude. It's like we just have to go to like Mypy's node stuff, which is nodes.py in our vendored Mypy, and then I gotta look for .node. Self.node is a symbol node, right? So basically, just to explain it in this analogy, this guy is, I guess, not a symbol node, but this dude is a symbol node, which makes sense. I mean, this all kind of checks out because Mypy doesn't need to check this guy. Mypy does its magic using this string thing. So we probably could ignore these indent. We can just complete the sync. When we do this sync after the fact, Mypy already has all the stuff it needs to check or needs to be checkable from Pyland. Adding this node is kind of invalid because this symbol's type is already represented by the function's overall type from the perspective of Mypy. So what we could do here is I'll just do this. This is also bad because this isn't type safe, but if has, come on, gimme, yes. Huh? No, not all that. No. Not, what are you doing? No, just take this. And put that here. And then take this and put that here. And if that's the case, oh jeez. Okay, if that's the case, don't give me a bunch of random code. Like, do this. Indeed, let's do it like this. Let's get rid of this. Else none. Now, if this is none, does this break? Let's see if it breaks. Yep. And we have solved the issue. So at least we've had a hypothesis. This is a partial solution because remember there's 19 places in the code that I need to update, and I only updated 2. But it is the solution approach for the case where this breaks. because it's an identifier part of the PyAST. And I don't think there's other, I mean, I would have to check to see if there's other non-identifier type sources of this issue, because these ASTs are fundamentally different. Even though there's a super setting, this AST has more stuff than Python. And so we'll have to make sure all of those more stuff nodes gets attributed to something Python-y, like some Python thing. Because at the end of the day, the bytecode is 100% Python. And the instructions the Python interpreter sees is going to correspond to every single semantic in the AST of a Jack node at the end of the day. So there's some linkage that's reasonable to create for all of the sources for additional nodes in Jack AST that isn't represented in the Python AST. So I think we're actually very close. I know I made it sound like we're really far, but we're actually very close, because I don't think there's that many weird occurrences. And we might be super close, but I don't know yet until I fix everything for the hardest file. So I'm gonna let me just commit this. I'm gonna make a note. No. I'll just say, to do may want to think about this approach more. All right, let's just approach about. Okay, so we'll do that. Let me do a git diff, make sure that it's pretty. Oh, what I'm checking for? I'm checking for printfs. Any debug code that I put in. This is just black being applied. Yep. This is type stuff. I'm doing a code review of my own code. By the way, it's very important. Or sometimes you'll miss weird stuff you put in. I don't have to check this, but let's I mean, it can't possibly pass a type check. Like, is this this file wouldn't pass a type check? Are these Mypy type checks errors? Yeah. I think he's no verifying his stuff. But from my diff, I could tell I didn't do anything type. I didn't add type errors. So, but let's see. Git add. Let's call it fix identified the issue, validated the fix, and fixed two issue sources. Very, very vague commit. I'm not going to give advice on commit quote styles. There's something called conventional commits. Read that doc. I don't follow a good commit discipline. Not a good example for that. All right, so whatever. I'm gonna do a no verify. Git add git commit no verify. Whoop. No, it's not verify. Git push. It committed. Git push. I already code reviewed it myself. Okay, and this is an unfinished PR. So, all right, I'll leave it there for now. I'm late to my meeting, but priorities. And thanks for watching, anyone who's still in, and I'll be back on. I'm going to try to be on more often. So, and I'm going to try to explain what I'm doing more and make it more understandable. So, awesome. All right, guys. Talk soon. Later.